In this video, we'll be talking about molar mass. So that's the average atomic mass on the periodic table. Except the molar mass, when you look at those masses on the periodic table, we're going to now think of them in terms of grams per mole instead of AMU. So you'll find them on the periodic table as it says here. And that's the mass of 1 mole of that element in grams. So an example, the molar mass of carbon, if you look on the periodic table says 12.011. That means that one atom has a mass of 12.011 AMU, but it means 1 mole of carbon atoms has a mass of 12.011 grams. So 12.011 grams is the mass of 6.022 times 10 to the 23rd atoms of carbon, or 1 mole of carbon. So now start thinking of those numbers in terms of grams per mole on the periodic table. So here's an example of 4 different compounds. You got water, sucrose, potassium dichromate, and salt. This is the molar mass of each of these substances. So you see 1 mole here. Now you'll notice they each have different masses. They take up different amounts of space, but what's the same about all 4 of these samples is there's 6.02. There's 6.02 times 10 to the 23rd molecules or formula units of each of these compounds. So different masses, but there's the same number of them. There's 1 mole of each. So think 1 mole of each substance. Now some hints to find mass, to convert, so we're talking about molar conversions, which will be next video. You need the molar mass, and that's found on the periodic table. Now, when you do the ladders, and again, this will be next video, just write it down for now, the mole equals 1 when you do the conversion. So you'll always put a 1 with the mole. Just like when we did unit conversions, the prefix gets the 1, now the mole gets the 1. So just take a mental note of that, write it down, save it for next video, and we'll be doing those soon. So the molar mass of a compound, what you do is you take the masses of all the individual elements and you just add them up. It's the sum of all the molar masses of each element. The units, remember this, grams per mole is the unit. And again, as it says here, it's found on the periodic table. It's the mass of 1 mole of a compound. Don't worry about sig figs and do not round on the molar masses. Just keep all of your places after the decimal, write it all out. So we're going to do an example. The first example, we've got KCl. This is potassium chloride. Now, it is made of 2 elements, so we're going to write out potassium and chlorine. You might have to pause the video to write this down to keep up, because I just click a button and they pop up, so you might want to pause to write this down. Now, there's 1 of each atom. So the first thing is you say, okay, in this formula, if there's no numbers here, we assume that there's 1 of each element. So we've got 1 potassium, 1 chlorine. Then if you look up on the periodic table, potassium is 39.098 grams per mole. And then this is the molar mass of chlorine. So these came from the periodic table. Now the next thing is I multiply how many atoms times its molar mass. So there's 1 of each, so pretty simple math there. There stays the same. Now, potassium makes up this much of the mass. Chlorine makes up this much of the mass. Now what I got to do is I got to add them together. And when I add them together, I get this number. This number is the mass of 1 mole of KCl. So if I want to weigh out 1 mole, or if I want 6.02 times 10 to the 23rd formula units of this compound, I would go to a scale and I'd weigh out this much of it. That would get me 1 mole. The next example, actually I'm going to go back. Now, again, this is equal to 1 mole of the substance. If I wanted 2 moles, obviously I'd have to weigh out 2 times this much. If I wanted a half of a mole, I'd have to weigh out half this much. So that leads into the next video. I just wanted to briefly mention that so that you kind of start to think along the lines of moles and molar mass and converting from moles to grams. Okay, what I want you to do here is I want you to pause the video, see if you can figure this one out. Now if you're back, I'm going to give you some hints. Maybe you need these hints. First thing, copper, nitrogen, and oxygen. This is how I would start it. There's 1 copper, because there's no number below it. Now this 2 distributes to everything in the parentheses. Now nitrogen doesn't have a number, so that means there's 1 of it, but then I have to multiply it by this 2. So there's really 2 nitrogens, and then the oxygens, 3 times 2, there's 6 oxygens. So at this point, that might get you started. Pause it and finish this if you think you can do it from here. Okay, now if you're back, the next step you got to look up, after we know how many of each element there is, I got to look up the molar mass of copper. It's 63.546. Nitrogen is 14.007, and I have a periodic table right in front of me. I'm looking these up. Oxygen's 15.999. So if you don't have a periodic table, you're not going to be able to do these unless you have all of this memorized. Now at this point, to solve for this, what you would do is you would multiply across. So 1 times this is pretty easy. I can do that in my head. 2 times 14 is 28.014. And then 6, I'm going to pull out a calculator and make sure I don't mess this one up. You get 95.99, oh, sorry, 95.94. Actually, it should have been 994. I typed it in wrong. 994. So I got a little messy there. Now, I know that copper makes up this much of the total mass, nitrogen makes up that much, oxygen makes up that much. Now I got to add them all together. When I add them together, 95.994 plus 28.014 plus copper's mass, I get a total mass of 187.554. Now don't forget your units. Your units are grams per mole. This is the molar mass of copper nitrate, or the mass. This is the mass of 1 mole of this compound. So if I want 1 mole, I go to the balance, I'd weigh out that much of it until the balance is 187. There we go. There's one more problem. I'm going to let you do this one on your own. Bring your note packet to class with this one done. We will do it in class. Maybe I'll have a volunteer do it on the board and see if you get it right.